In this video, I'm going to teach you how to solve rational equations. Now, there's one technique that always works, and that's to get like denominators and then cancel out all of the denominators. So I can look at this negative 6 as being negative 6 over 1. If I wanted to have like denominators with the left side, it's going to need an x plus 5. So I can go ahead and put x plus 5 in the denominator as long as I also multiply the numerator by x plus 5. So now that we have like denominators, you can essentially cancel those denominators out and still have a valid equation. So the new equation is 3 is equal to, and normally I would skip this step, I'll just go ahead and show it. Alright, so I have 3 is equal to this. I cancel out those denominators. But you could go ahead and do the distributive property. So I have 3 is equal to negative 6x minus 30. I would then add 30 to both sides. So that's going to be 33 is equal to negative 6x. And then I would divide both sides by negative 6. So x equals. I'm just going to reduce this. I'm noticing that both of these are divisible by 3. So that's going to be negative 11 over 2. So that will be the answer to problem number 1. Now obviously that was very simple and it will get more complicated. Now I'm going to use the same technique for all of these problems. So again, I want like denominators and then I'm going to cancel them out. Now here, let me tell you something that I cannot do. You see that this side has an x minus 1. I can't just put a minus 1 here to make these the same. All you can do is multiply to make the denominators the same. So I'm going to have to look at this as two separate things, an x and an x minus 1. So if I want to make the right side look more like the left side, I'm going to have to put an x minus 1 in the denominator and the numerator. Alright, now they look almost the same, but the right side has x times x minus 1. So I'm going to have to do the same thing on the left side and put an x. Alright, and I will need to put that in the numerator and the denominator. Okay, now that I have like denominators, I can go ahead and cancel out the denominators and still have a valid equation. Okay, so now I have x times 2x minus 3 is equal to 2 times x minus 1 without the denominators. And then you do the distributive property. So that's going to give me 2x squared minus 3x is equal to 2x minus 2. I'm going to need to get 0 on one side and try to factor. So I'm going to subtract 2x from both sides and add 2 to both sides. So that's going to give me 2x squared minus 5x plus 2 is equal to 0. So now I'm going to go ahead and try to factor this. Hopefully this will factor. Maybe I'll jump up and put it up here. So here I go trying to factor. 2x squared can only factor as 2x times x. 2 can only factor as 1 times 2. Now it could have been 2 times 1, but that would create a common factor inside of the parentheses, and I don't waste my time on that because that will never be the answer. So I will skip to putting the 1 here and the 2 here. Now inner plus outer must equal middle. Inner I have 1x, outer I have 4x. I'm trying to get negative 5, so that means both of these would have to be negative, which means these would be negative. It works also because negative 1 times negative 2 is positive 2. So now that we have factored correctly, according to the zero product property, I can find the solutions by setting each of these equal to 0. Adding 1 to both sides will give me 2x equals 1. Dividing both sides by 2 will give me x equals 1/2. Adding 2 to both sides will give me x equals 2. So these are my two solutions to the equation for problem number 2. Always be aware of your excluded values. All right, looking back at the original problem, I know that x cannot equal 1 and x cannot equal 0, just looking at your original problem. So always be aware of your excluded values, and always make sure that none of your answers were excluded values. In fact, I'm going to look back at problem number 1 because I forgot to mention my excluded values. X cannot equal -5. All right, looking at the denominator there. All right, that's excluded. Okay, I'm looking at number 3. Very often there's going to be factoring to be done. So if you see something that'll factor, go ahead and factor it. So x squared minus 9, that's the same thing as x plus 3 times x minus 3. Okay, and this is like having 4 over 1. So I need like denominators. So the left side has x plus 3, x minus 3. So the right hand side also needs x plus 3, x minus 3. All right, now you have to put that in the numerator and the denominator to make sure that you're not really changing anything. Once you have like denominators, you can cross them out. So I have like denominators right now, so I cross them out. Now it would be a good time to say what the excluded values are, though. So notice that x cannot equal 3, x cannot equal -3. These are my excluded values, and you can see that in the factored form. Anyway, now I have x squared is equal to 4 times x plus 3, x minus 3. If I multiply these together again, I'm just going to get x squared minus 9 back. Of course, because that's how we got x plus 3, x minus 3 in the first place, was by factoring x squared minus 9. So obviously if we multiply it back together, I'm going to get back to x squared minus 9. But this is the form that we need to finish the problem. If I do the distributive property now, then now I have x squared is equal to 4x squared minus 36. Now I need everything on one side, and I like my leading coefficient to be positive. So you know what? Now I'll go ahead and just move it to the left. So I'm going to subtract 4x squared from both sides. Okay, so I'm just going to move this temporarily. So that's going to give me -3x squared is equal to -36. All right, because this is like a 1. 1 minus 4 is -3. Now it's time to divide both sides by -3 to get the x squared by itself. So dividing by -3, so those cancel out. And now I have x squared is equal to positive 12. And now I need to take the square root of both sides. When you take the square root of both sides, don't forget your solution can be plus or minus. So you have to remember the plus or minus. So I have x equals, and we should simplify this down. All right. 12 is 4 times 3, so you should be thinking, okay, this is the same thing as the square root of 4 times the square root of 3. And of course, the square root of 4 is 2, so this will be 2 radical 3. So these are the two solutions to this equation. And don't forget your excluded values. X cannot equal -3, x cannot equal positive 3. Okay, let's keep going. Let's do the same exact thing for number 4. We're going to get like denominators. So look, I have 5x over x minus 1. Okay, Now, this 2, think of that as 2 over 1. And then I have 14 over, and I might as well go ahead and factor this out. So this will be x plus 1 times x minus 1, because difference of 2 squares. Now, all 3 denominators need to be the same, all right, including the denominator under the 2. A lot of times students forget about the constant that's sitting there. That counts, all right? It has its own denominator. Okay, so look at this denominator that has the most in it. X plus 1, x minus 1. That means all denominators will have to have x plus 1 and x minus 1 to match. This denominator already has x minus 1, so it just needs x plus 1. All right, numerator and denominator. Now this denominator doesn't have anything, so it's going to need both. So I'm just going to move this 1 out of the way. So I'm going to put x plus 1 and x minus 1 in the denominator and the numerator. Okay, now we have like denominators. Once you have like denominators, you can just go ahead and cancel them out, and you will still have a valid equation. So now I have everything that's in the numerator, but I think I will go ahead and do the next step. So I have 5x times x plus 1. All right, this is -2. Think of it as a -2. Now, if you multiply these together, see you later, you're going to get x squared minus 1. And we know that because that's where it came from in the first place, as factoring x squared minus 1 turned into x plus 1, x minus 1. So obviously, if we multiply it back together, it'll turn back into x squared minus 1. So this is really -2 times x squared minus 1 is equal to 14. So this is what we have. When you do the distributive property, make sure you are distributing -2. All right, this minus sign became a negative on this 2. So distributive property here gives me 5x squared plus 5x. All right, distributing the -2 gives me -2x squared plus 2. All right, -2 times -1 is +2. And all of that equals 14. Now I'm going to combine my like terms. 5x squared minus 2x squared, that's going to make 3x squared. Those are my only like terms there. So far I have 3x squared plus 5x plus 2 is equal to 14. But I need 0 over here, so let's go ahead and subtract 14 from both sides. So now I have 3x squared plus 5x minus 12 is equal to 0. Okay, now I'm running out of space, but I'm hoping this will factor. 3x squared can only be 3x times x. 12. 12 can be many things. Maybe I'll just put my little list of 12s over here. All right, this is either going to be 3 times 4 or 2 times 6 or 1 times 12. Those are the possibilities. Okay, let's start with the 3 times 4. Don't put the 3 first, because that would make a common factor. Instead, skip to the option that goes 4 here and 3 here. Inner plus outer must equal middle. Inner, I have 4x. Outer, I have 9x. I'm trying to get +5. I can get that if I have a negative 4 and a positive 9. So that means negative here and positive here. Negative 4 times positive 3 is negative 12, so that's it. We did it. Okay, so that's how you factored it. Now, setting each of these equal to 0, okay, that's going to give me, if I add 4 to both sides, that means 3x is equal to 4. Dividing by 3 gives me x equals 4 over 3. Subtracting 3 from both sides gives me x equals negative 3. Okay, so I'll just go like this. These are my two solutions to this equation. Let's see if I can just squeeze in my excluded values. All right, looking at the factored form makes it most obvious. See the +1 and the -1? Those are my excluded values. X cannot equal -1. X cannot equal +1. Those are my excluded values. Okay. All right. Now on this one, notice that we already have like denominators. So we can just skip to the part where we cancel these out. So we can go straight to 5x minus 7 equals 8. Okay, so I'm just going to add 7 to both sides. So that'll give me 5x is equal to 15. And then dividing both sides by 5, we discover that x is equal to 3. So that's the solution. Excluded values, looking back at the original problem, x cannot equal 2. All right, I'm just setting the denominator equal to 0. The denominator can't equal 0. So that's it for number 5. All right, how about number 6? Now, remember to treat each of these three separately. So I need all of these denominators to be equal. Okay, now, the only denominator I see right now is x. So I need the 3 to have a denominator of x as well. All right, which I can have as long as I put an x in the numerator too. And I need this first term, the x, to have a denominator of x. And that'll be okay as long as I multiply the numerator by x as well. So now I have like denominators, so I can go ahead and cancel these denominators out and end up with a valid equation. Now x times x is x squared, so I have x squared minus 4 is equal to 3x. Subtracting 3x from both sides, notice I put it in the middle, standard form. So now I have x squared minus 3x minus 4 is equal to 0. Okay, now perhaps this is factorable. X squared can only be x times x. 4 is either 2 times 2 or 1 times 4. I think it's going to turn out to be 1 and 4. Inner plus outer must equal middle. Inner, I have 1x. Outer, I have 4x. The middle is negative 3. So I will get that if I have a positive 1 and a negative 4. That'll make negative 3. So there's my positive 1, there's my negative 4. Also, positive 1 times negative 4 is negative 4, so it's working. Once you have it factored, you can use your zero product property to find your solution. So x plus 1 equals 0, x minus 4 equals 0. Subtracting 1 from both sides gives me x equals negative 1. Adding 4 to both sides gives me x equals 4. So these are the two solutions. All right, looking at number 7. Okay, again, I need like denominators. Here I have a denominator of x plus 2. So I'm going to put x plus 2 in the denominator, and therefore I also must put it in the numerator. And that's it. I now have like denominators, so I can go ahead and cancel them out, and I will still have a valid equation. So I have x squared plus 1 is equal to 3x minus 1 times x plus 2. I'm going to go ahead and multiply this together. Okay, double distributive property. So I have x squared plus 1 over here. 3x times x is 3x squared. 3x times 2 is 6x. And then negative 1 times x is negative x. Negative 1 times 2 is negative 2. I've got the like terms, so I've got 3x squared plus 5x minus 2. All right, just combining my like terms. Now I need 0 on one side. I think it'll be easier if I subtract these two and get 0 on the left. So if I subtract x squared from both sides, and I'm going to subtract 1 from both sides. So that will leave me with 0 over here on the left. 3 minus 1 is 2x squared. Then just bring down the 5x. Negative 2 and negative 1 is negative 3. So I've got that. Okay, let's see if this is factorable. $2x squared can only factor as 2x times x. 3 is either going to be 3 times 1 or 1 times 3. Okay, if I do 3 times 1, inner plus outer must equal middle. Inner, I have 3x. Outer, I have 2x. To get a positive 5, both of these would have to be positive, which would mean both of these would have to be positive. But this does not work because I also have to get negative 3. And positive 3 times positive 1 would be positive 3. So this was very close because I'm getting the middle, but it is wrong because I'm not getting negative 3. So it must be the other way. So instead of doing 3 and 1, I will try 1 and 3. Inner plus outer must equal middle. Inner, I have 1x. Outer, multiplying, I have 6x. To get positive 5, I need a negative 1 and a positive 6. So this will give me a negative 1, and this will give me a positive 6. Now, negative 1 times 3 is negative 3, so it is now factored correctly. Okay, setting each of these equal to 0, also known as the zero product property, will allow me to get the solution. So adding 1 to both sides, I have 2x equals 1. Dividing by 2, I have x equals 1/2. Subtracting 3 from both sides, I have x equals negative 3. So these are the two solutions. Okay, what are the excluded values? Looking back, the only denominator I had was x plus 2. If I set that equal to 0 and solved, I would get negative 2. So x cannot equal negative 2, so that's just good to keep in mind. Okay, one more problem, number 8. Okay, I see that these are expressions that can be factored. So let's definitely do that. So I have 4 over, and x squared minus 16 will factor as x plus 4 times x minus 4. Then I have plus 5 over x plus 4. All right, I'm leaving space because I'm looking ahead and I see that I'm going to have to add some stuff. So I'm just leaving room. And over here, I have my x plus 4 in the numerator, and this is the same as this. So again, x plus 4 times x minus 4 when you factor it. Okay, we can already see what the excluded values are going to be, by the way. X, based on these denominators, x cannot equal negative 4, and x cannot equal positive 4. So that's good to keep in mind. But we need like denominators so we can cancel them out. Looking at the first fraction and the last fraction, they both have x plus 4 and x minus 4. So we need to make this be x plus 4 or x minus 4. So what it needs is an x minus 4. So you put that in the numerator and the denominator. Now we have like denominators, so cancel them out. That's going to leave us with 4 plus 5 times x minus 4 is equal to x plus 4. Don't add these. Order of operations, you have to multiply before you add. So this will give us 4 plus 5x minus 20 is equal to x plus 4. Okay, so I got some like terms here. So this is going to be 5x minus 16 is equal to x plus 4. All right, just combine the 4 and the negative 20. Now, I want to get my x's on the left and my numbers on the right. You all right? Just trying to get x by itself. So I'm going to subtract x from both sides. All right, I'm pulling my x's over to the left. And I'm going to add 16 to both sides. All right, that way I'll have my numbers on the right. Okay, so these cancel out. So 5x minus x is 4x. And then 4 plus 16 is 20. So dividing both sides by 4, I'm going to get x is equal to 5. Okay, so that is my one and only solution. And I'm going to go ahead and write down those excluded values now. X cannot equal negative 4. X cannot equal positive 4. All right, that is the end of this lesson. I hope it was helpful, and I will see you on the next video.